Alright guys, today's goal, the learner will understand inverse trigonometric functions. State the sign, positive or negative, sine, cosine, tangent in quadrant 1. So, quadrant 1, they're all positive. Quadrant 3, negative, negative, positive. Cosine of pi over 6, square root 3 over 2. See, tangent of 4 pi over 3. That would be positive, let's see, it would be sine over cosine, so it would be square root 3 over 2 divided by 1/2, which is square root of 3. I think that's right. Negative 11 pi over 6. 1/2. Let's see. There we go. That unit circle, we got to know it. What you'll learn about: inverse sine function, inverse cosine and tangent, composing trig and inverse trig functions, applications of inverse trig functions, and why inverse trig functions can be used to solve trigonometric equations. Alright, the inverse sine function. Okay, so what they look at is the sine function from negative pi over 2, where it's at negative 1, to positive pi over 2. So, and then so this one, the domain, is negative pi over 2 to pi over 2. In the range, negative 1 to 1. Well, the inverse is only flip it. So it's very confined. The domain is between negative 1 and positive 1. And the range is between negative pi over 2, pi over 2. So there's no end behaviors. It is continuous throughout this range. And it's an odd function. Okay? Because if you reflect it over the line y equals x, it's odd. Okay? So inverse sine function. The unique angle is the interval c at negative pi over 2, such that the inverse sine, or arc sine, that's another way to say it, they're denoted one of those two ways. So the domain is negative 1 to 1, and the range is negative pi over 2 to pi over 2. Okay? Find the exact value without a calculator. The inverse sine of negative 1/2. Alright. So remember though, we're restricted between negative pi over 2 and positive pi over 2. So it would be in quadrant 4, because it's negative, so you know it's negative. And 1/2 is when it is the pi over 6. Okay? There you go. So the sine of pi over 10 and then the inverse sine of pi over 10, well, those are inverse operations, so it just equals pi over 10. So if I had this, it equals x. Okay? Cosine. Now cosine, do you see what it's restricted from 0 to pi for the domain, and it goes negative 1 to positive 1. So if we, for the range, so if we flip it, the domain negative 1 to 1, the range 0 to pi. Here's the same thing for cosines. Okay? Tangent. Well now, tangent, the domain of tangent for this is negative pi over 2 to pi over 2. Notice They're parentheses, not the brackets, because it never equals that. The range, though, negative to positive infinity. So here our domain now is negative infinity to positive infinity. And our range is between negative pi over 2, pi over 2. Now this one has an end behavior because it goes to positive and negative infinity. You can see what it is. It's either negative pi over 2 or pi over 2. Okay? There we go. And see end behaviors. The following equations are also always true whenever they are defined. So they have to be defined by their domain and ranges. Okay? So all of these are true. This is something we need to get to know. Alright, so compose each of the 6 base trig functions with the inverse sign and reduce the composite function to an algebraic expression involving no trig functions. Okay. So we're using inverse sign, which is why we set this up. If it was cosine, the x and the 1 minus x squared of 1 minus x squared would switch. We're using 1 as the hypotenuse because we're using the unit circle. Okay? So what they mean by this is they want you to say the sine of the inverse sine of x equals x. The cosine of the inverse sine of x equals. Okay. So we know the inverse sine of that angle is that angle. What's the cosine of that angle? Well, it's square root of 1 minus x squared over 1. The tangent of the inverse sine of x is x over square root of 1 minus x squared. Now if we think about cosecant here, if the inverse sine, the sine of the inverse sine of x is x, then the cosecant of the inverse sine of x is going to be its inverse, so 1 over x. And the secant of the inverse sine of x is going to be 1 over the square root of 1 minus x squared. And then the cotangent of the inverse sine of x, square root of 1 minus x squared over x. So basically what they're saying is when you take the inverse sine of that angle, it doesn't really matter. When you set it up, these are always the ratios for all of them. Okay? So there we go. See you guys tomorrow.